So to resume our discussion on the dispersion measurements, we mentioned variance and standard deviation, and we suggested that MED is a better measurement when you have extreme outliers. The reason that we wanted to, after we have variance, we also want to have standard deviation is because standard deviation have some very convenient properties when your data are normally distributed. So for example, when you have normal distributed data, you can say that from the mean, from the one standard deviation range covers 68% of all the data. And 2 standard deviation range covers 95% of the data. And the 3 standard deviation range from -3 to +3 covers about 99.7% of all your observations. So when you have a normal distribution, knowing this, you will be able to fairly easily find outliers. For example, anything that's 3 standard deviation away are most likely are outliers, right? And now earlier we talked about all those quantiles, range, and all that. And I promised that when we look at Boxplot, everything going to make sense. So Boxplot is a very powerful way to illustrate the 5-number summary of a distribution. A 5-number summary consists of the minimum value, the maximum value, and the 3 quantiles. The quantile 1 from the minimum, the quantile 1 covers a portion, 1/4 of all the observations. The quantile 2 also cover one portion, 1/4, a quarter of all observations, and quantile 3 the same. So the box plot can be plotted horizontally or vertically. So what we can see here, using any one of those examples, maybe using this one is easier. So this is the smallest value. This is the largest value in this box plot. And this is Q1. So Q1 is one point in this distribution. From the lowest range to Q1, here covers 1/4 of all the observations. And then this is Q2, also called median, right? Q2 and median, the same thing. This from Q1 to Q2 again covers quarter of all the observations. And then from Q2 here, the other end of the box is Q3. And this again covers a quarter of all the observations. From Q3 to the upper extreme, which is the largest value here in the data set for this attribute, covers another quarter of all the observations. So the difference between upper extreme and lower extreme is the range. And the average between these two was the mid-range. Okay, so now we explained all the terms again that we listed here visually using Boxplot. Many variations of Boxplot exist, and you can present this vertically or horizontally, as I mentioned earlier. In this variance, not the lower and the upper extreme are not depicted, but the outliers are. So I'm going to explain this variance. So what I forgot to say here, because this is Q1, this is Q3, so this range, the value from here to here is the IQR, the interquartile range. Okay, this is the same here too. But in this representation, this line, this is called whisker, so whiskers. So those two lines extending outside the box illustrate the minimum and maximum value within the 1.5 IQR. Earlier we mentioned outside of 1.5 IQR, greater than or lower than 1.5 IQR, we would consider them to be outliers. So here the whisker extends to the minimum and maximum value that are not considered outliers. And if they're outliers, they're going to be depicted outside of either above or below those whiskers. So the box plot gives you a very visual way to look at how the data is distributed. We can see in this example, we can see data is symmetrically distributed and it's almost normal because everything is symmetrical, right? The mean is close to the place that divides the portions, but it has a few outliers. And we can see in this plot that data is skewed because this portion covered a small range of value covered the same number of observation, and this range have larger value range covered the same number of observation. So this box plot shows that the data is skewed. And also visually, you can see how many outliers are there. In R, in our exercise, I showed examples how to make box plots. And this is our second style, where you have whisker and outliers. Other more advanced that you can actually plot multiple attributes in one screen, that you can see how for every attributes, how the values are distributed. So here, this box plot, for example, shows that, oh gosh, if I can read this. Okay, this is small, medium, large. So what this facet grid depicts is actually the, okay, so step back. So this was the algae data collection that we used in our R exercise. This collection of data, the researchers measure algae bloom in algae growth in different seasons at different size of water, so large, medium, small water bodies, and the speed of the water in that body. So whether it's river or it's pond, so the speed have high, low, medium, and the size of the water body is small, medium, large, and also the season. So all those three are context attributes. And the researcher measures want to learn algae growth under this context and with different chemical concentration. So A1 is one of the chemical. So here, this group box plot is trying to show concentration of A1 under different combinations of the conditions that we have. So in this case, we have high speed in small water at autumn. So this is how the A1 concentration are among those water bodies. So this box plot again show us that there's not an outlier, but the data are squarely distributed. So A1 concentration was not under the three combination conditions were not normally distributed. There are other ways, 3D and other way to plot box plots. I'm going to stop here and start a new video to cover other graphic type graphic displays of the basic statistical descriptions.